Today's video will talk about the Pearson R test of significance. Pearson R tests use interval data. So anytime your data is in the form of a number, that is interval data. So some of the types of data that you might see would be scores, scales, tests, numbers, anything like that. Pearson R's also test the hypothesis of association. So the hypothesis of association is when you are looking at the relationship between two variables, not two groups, just two variables. So some of the keywords that you might see would be relationship, correlation, association, anything that would imply a relationship between those two variables. When you are dealing with the hypothesis of association, the variable is also assigned. That means that your participants have this already. It is not something that the researcher is trying to change. It is something that the participant already has. It's like their height, their eye color, things like that. A researcher wants to see if there is a relationship between time spent online and number of shoes bought. Now, looking at this problem, how do we know that this is a Pearson R? Well, a Pearson R has certain characteristics that only a Pearson R would have. So let's take another look at the problem and see if we can pick out some of the details that might let us know for sure that this is a Pearson R. So let's look and try and identify our independent and dependent variables. So what is our independent variable? The independent variable is what the researcher is manipulating, what they are changing. Now in this instance, it is the time spent online that is the independent variable. So time online. Okay, now that we know that, what is our dependent variable? What is it that at the end of the research, the researcher is looking at, is measuring? This would be the number of shoes bought. So number of shoes. Are there any key words in this problem that we might want to keep in mind for later? This word, relationship, really sticks out. Relationship, correlation, association, those words like that, that'll tell you a lot about the problem that you're looking at. So one of our key words is relationship. Okay, now that we have all of that together, what kind of data are we dealing with? Are we dealing with nominal? Are we dealing with ordinal or interval? Now, since we have our dependent variable of number of shoes, that means that our data is in the form of numbers. So that is going to mean that our data is interval. And for the last part, are we looking at a hypothesis of association or difference? Now, a hypothesis of association looks at the relationship of two variables. Since we have this keyword here, relationship, and we have our variables of time online and number of shoes, that means that we are dealing with a hypothesis of association. And since a Pearson R deals with interval data and a hypothesis of association, now we can be sure that we are dealing with a Pearson R. So this is the table that we have been given based on our previous problem. So before we start dissecting that or solving for anything, the first thing that you really need to do is get your formula together. Figure out what formulas you need in order to solve the entire problem. Get your degrees of freedom together, get your standard deviations, get your mean formulas if you need them, whatever formulas you need in order to completely solve the problem. Get those all together and put them in one spot because that's really going to help you down the line from having to look for them while you're trying to solve it. So I have already written these down. I've got the R value, I've got the standard deviation, and the degrees of freedom formulas. Now, after those are all written, take out what pieces of the formula you are going to need. So we are going to need our M for X, our M for Y, standard deviations for X and Y, our N values, all of that. Take out every single piece out of the formulas and figure out what you need. So I've made a list over here of what we need. Just like I said before, we need the means for X, the means for Y, the standard deviation for X, the standard deviation for Y. So keeping a table like this, even on a side of scratch paper, is really going to help you keep everything organized. And then when you go to solve the formulas, all that you have to do is look at your formula and take the numbers from here and plug them right in and then just solve. And it makes things a lot easier. Okay, so what I've done here is I have just taken the information from the previous table and just expanded it a little bit. This is completely optional. You don't have to do this. Just in my experience, it was easier for me to take the information and just make it a little bit bigger, and that way I could just keep everything a little bit more organized. So all that I did was I took the information from the table, the time spent online, and the number of shoes bought. I assigned an X value to time, and then I put an X squared column next to it. I assigned a Y value to shoes, put the Y squared column next to it, and then did an XY column as well. And then underneath all of these, I just put the sum for each column. So the sum of X and the sum of X squared and so on. Okay, so let's go ahead and start filling out this table. So for our X squared value, we're just going to take our first value here and square it. So it's going to be 5 squared is going to be our first value. So 5 squared is 25. And then 3 squared is 9. 1 squared is 1. 6 squared is 36. 7 squared is 49. Okay, and then we're just going to do the same thing for the second column. So 1 squared is 1, 1 squared is 1, 0 squared is 0, 4 squared is 16, and 5 squared is 25. Now for our XY column, we are going to multiply the values in our X column and our Y column. So we're just going to go straight across. So we have 5 times 1 is 5. 3 times 1 is 3. 1 times 0 is 0. 6 times 4 is 24. And then 7 times 5 is 35. Okay, now that we have all of that filled out, we can add all of these numbers up and put them into the spots below. So the sum of X for here, which this symbol, sorry, my drawing is super good. That symbol means the sum of, or to add everything up. So now that we have all of our numbers in here, we can go ahead and add those up. So we're going to add 5, 3, 1, 6, and 7. That is going to give us 22. We're going to add 25, 9, 1, 36, and 49. And that is going to give us 120. 1, 1, 0, 4, and 5 all added together is going to be 11. And then 1, 1, 0, 16, and 25 all added together is going to give us 43. And then 5, 3, 0, 24, and 35 is going to get us 67. Now with that information, we can go ahead and start solving for our means and our standard deviations and all of that. So I've just taken the information that we figured out using the last table and just condensed it a little bit just to give us a little bit more room. So these are the answers that were all at the bottom of the table, minus our n value, which is how many people we have in our study, which was 5. So now we have all the information that we need to go ahead and actually start plugging numbers in and working out our formulas. So let's go ahead and find the mean for the X column. So we are going to take EX, which is 22, and we're going to divide that by our N value, which is 5. So when we divide 22 by 5, that's going to give us 4.4. Okay, so our MX is going to be 4.4. Okay, so now let's do MY. So we're going to do the same thing, but with the EY value. So we have the value of 11 divided by 5 once again, and that is going to give us 2.2. So now our my value is 2.2. Okay, and let's go ahead and figure out degrees of freedom as well. The formula for degrees of freedom is n minus 2. We already know that our n value is 5, so if we take 5 and subtract 2, that is going to give us 3. So I have gone ahead and written the majority of the information on a piece of scratch paper over here that I'm going to continue to use. So I put in our mx value, I put in our my value, I put in the ex squared, the ey squared, exy in, and then now we have our degrees of freedom, which is 3. So we can go ahead and put that in there too. So you can kind of see that all of the numbers that we need are slowly filling up the table. And then as we continue to solve our equations, we just pull numbers from this table. So it just makes it a little bit easier.